Over a period of time, Jasper has found that the time it takes him from getting out of bed to walking in the school gates is normally distributed with a mean of 50 minutes and a standard deviation of 5 minutes. He is classified as late if he arrives after 8:30. What is the probability that Jasper is late if he gets up at 7:58? If he gets up at 7:58, he has 32 minutes to get to school. So if this is his normal distribution and the mean is 50, 32 minutes is over here. Now we should say before we start that the time it takes him to get to school is normally distributed with a mean of 50 and a variance of 5 squared. Now we want this probability because if it takes him longer than 32 minutes, he's going to be late. So the probability of t being more than 32 we can find using a suitable calculator, in my case the ClassPad. And so we have continuous, it will be a normal CDF, and the lower is 32 and the upper would be infinity with a sigma of 5 and a mu of 50, giving us 0.9998. So he's very, very likely to be late under those circumstances. Over a period of time, Jasper always gets up at the same time and finds he's late 55% of the time. What time is he getting up? So in this situation, this is his distribution. He's getting up at some time here, and the area here is 0.55. So we know the probability, we want the time, that's an inverse distribution. So we are going to go to the inverse normal. Our tail is on the right, as we can see from the shading here. That's 0.55. That's going to be 5. That's going to be 50. And so 49.37 minutes. So we need to count that back from 8:30, which is when he would be late. So we're going to take that amount of time off of that. And so he's going to be getting up at approximately 7:41. So in part C, Jasper's happy with the mean of 50 minutes, but aims to make himself more consistent. So in other words, he's going to change the standard deviation. Over a period of time, he finds that it takes 52 minutes or more, 20% of the time. What's his new standard deviation? So his time is now going to be a normal with the mean still of 50, but we don't know the standard deviation. What information do we get from the question? So the mean is still 50, but the time it takes him is 52 or longer, 20% of the time. So we have all the information we need to work out the new standard deviation here. And a way we can do it is to use a normal CDF, but we need to do it with a solve. So we know that the probability is 0.2. And what we're going to do with the normal CDF is say, well, the lower is 52, The upper, of course, is infinity. We don't know the sigma, so we can put an x in there. And the mu is still 50. And this should give us the answer. And it's 2.38. So his new sigma is 2.38.